Welcome to The Deep Dive, and a special welcome to everyone on the Deep Dive Canada channel. We're here to cut through the noise and, get straight to what you need to know.
And today's mission is a big one.
It really is. This dive is, it's custom tailored for you, the learner, if you need to get your head around a truly huge topic, and fast. We're talking about how one of the world's great mountain ranges was formed.
Yeah, and the source material we're digging into is called Excerpts from the Formation of the Canadian Rockies.
Okay.
So our job here is really precise. We're looking for that one single foundational idea that unlocks everything else. The whole thing really boils down to one critical question from the source material itself.
And that question is?
How are the Canadian Rockies made?
That's it. That's our target, the geological blueprint. And we're going straight for the answer this time because that's the knowledge you actually need to master this. So let's start with the basics, scale and time.
Well, what's fascinating is that the word formation in the title itself tells you so much. It sets up a scope, both in time and in, physical scale, that most of us can barely comprehend.
Right.
We're talking about an orogeny, a mountain building event, specifically the Laramide orogeny.
And this wasn't like a volcano erupting, not a sudden thing.
Not at all. This was a process that went on for over 125 million years. It mostly ran from the middle of the Mesozoic era.
The age of the dinosaurs.
Exactly. About 180 million years ago, and it really wrapped up around 55 billion years ago.
That is just an immense amount of time. So when people think big mountain,
right,
I feel like they often jump to volcanoes.
Yeah.
Huge forces, fire, magma.
Yeah, that's a common thought.
But the sources hint that the Rockies are different. Why aren't they volcanic, even though they came from this massive continental collision?
And that is the absolute core piece of knowledge you need to grasp. The Rockies are what we call fold and thrust mountains. They're not volcanic.
Okay, so fold and thrust.
Right. They're the result of just immense horizontal compression, not vertical magma shooting up. This was a slow-motion collision. You had the Pacific plate sliding under the North American continent, a process called subduction, and that pushed all of this stress deep, deep inland.
So pressure that could literally crumple miles of the Earth crust like it was tinfoil. But it's coming from the side.
Exactly, from the side. So we need a way to describe that crunch for you, the listener, the actual mechanism that lets the planet build mountains this tall without just melting everything.
Okay, what's the mechanism? It's
called thin-skinned thrust faulting.
Thin-skinned?
Right. So imagine you have hundreds of miles of ancient sedimentary rock. This is mostly softer stuff, limestone, shale, sandstone, that was laid down in a shallow tropical sea a long time ago.
Okay, so flat layers.
Perfectly flat, just lying there. When that tectonic force arrived from the west, the pressure basically scraped these horizontal layers right off the harder, more rigid rock underneath.
Whoa. So instead of just folding up like a blanket, they were sort of stacked or shingled on top of each other, but violently.
That's a perfect way to put it. The pressure created these huge low-angle fractures. Those are the thrust faults. And that allowed older, deeply buried layers of rock to slide up and over younger layers.
And they moved a long way.
A very long way, sometimes 50, even 100 kilometers sideways.
Mm-hmm.
That stacking is what gives the Canadian Rockies their incredible height and their unique layered look. Geologists call this crustal shortening.
Crustal shortening. That's the key insight, isn't it?
Yeah.
You're saying hundreds of miles of the continent's crust got squeezed into the, 50-mile width of the range today?
That's exactly it. The land literally got thicker, and the only place for it to go was up, skyward.
And once you understand that how, it immediately gives you the context for the actual stuff the mountains are made of.
Yes. If you connect this to the bigger picture, the materials are everything, because these mountains are built from uplifted sedimentary rock.
The stuff from the bottom of that old sea.
Right. Rock that's sometimes 500 million years old. So it has very specific characteristics. It's full of marine fossils, for one. It has massive amounts of limestone. And critically, those porous sedimentary layers, when they were squeezed by the heat and pressure of the orogeny, they became the perfect reservoirs for the oil and natural gas we find right next to the mountain front.
It really connects everything, doesn't it?
Mm-hmm.
The geology, the geography, even the economy. If you know the forces, you know the materials.
And you know how they react to things, like erosion.
Which brings us to the next part of the story, I assume. The formation story isn't over once the mountains are built.
Not at all. That leads us to the final stage. So the Laramide orogeny created the bulk, the height. The major uplift stopped about 55 million years ago. But the way the Rockies look today, all rugged and dramatic, that's the result of erosion. primarily glaciation.
So the glaciers are the sculptors.
The ultimate scripters. Those uplifted layers were already broken and fractured from all that thrust faulting, which made them really vulnerable to weathering. The high elevation meant the mountains went through repeated ice ages, and the glaciers acted like giant bulldozers, just scooping out those iconic U-shaped valleys and sharpening the peaks into what we see today in Alberta and BC.
So it's really a two-part story.
A two-stage process, exactly. First, the slow tectonic build over millions and millions of years. Then, the dramatic carving and shaping by ice and water over the millennia that followed. The question, how are they made, really needs an answer that covers both.
So let's recap the factual framework for everyone. The Canadian Rockies are the result of the Laramide orogeny,
Yep.
which involved massive crustal shortening through thin-skinned thrust faulting,
Of ancient marine sedimentary rocks.
which were then sculpted by massive glaciers. That's the knowledge you need. We went from just looking at the title to the full answer.
And that information, that specific mechanism, is the foundation. It lets you understand everything else about the Rockies.
Okay, so before we go, I think you got a final thought for us to mull over.
I do. A little provocative thought for you.
I'm ready.
So we've talked about the vast geological time involved in the build, a process that was mostly done 55 million years ago. Given the sheer scale and the fact that 55 million years of erosion has happened since they stopped growing, what percentage of their original absolute maximum height do you think has been worn away by ice and water? That tension, between the creation and the decay, that's where you can start to really appreciate what these mountains are.
That is some serious food for thought. Thanks for tuning in to the Deep Dive Canada. Don't forget to comment, like, and subscribe for more deep dives. See you in the next episode.